Good morning, students. So we'll move on to the second layer of IoT simplified architecture, that is communications network layer. So in previous lecture, we were discussing about the first layer, that is the things or the actuators. So from the previous lecture, we discussed like what exactly simplified IoT architecture is. Okay, the general working principle of those layers. Okay, what are the three different layers we are dealing with over here. First one is the things or the actuator. So in yesterday's class, we discussed like how many different kinds of classifications are available regarding the sensors and what is the working principle of those sensors and okay, regarding that we had a discussion. So today we need to discuss about the intermediate layer, that is what the communication network layer. Okay, I want to tell you one thing, like this is what the layer who is generating the network, okay, for connectivity. Okay, so we have a smart device, we have application software. Okay, between that we need to provide a connectivity. For that, what we need to do, we need to establish a communication network over there. Okay, so we'll go through. Once you have determined the smart object transmission capabilities like transmission range, data volume and frequency, or else sensor density and mobility, you are ready to connect the object and communicate. Okay, see, first thing what we need to do, from base we need to start designing. Remember, okay, first we need to decide what kind of sensor we are going to deploy over. Okay, sometimes it will be wired based, sometimes it will be wireless, battery based. Okay, like online power supply it may be. Okay, such type, what kind of device it is, that should be decided first. According to that, we need to go for a designing a network. Okay, so the network, whatever we are using, or the computer or network asset, okay, whatever we are using in the IoT, okay, will be totally different when we are comparing with the IT environment. Okay, then later the operational difference must be understood in order to apply the correct handling to secure the target asset exactly. Okay, so the asset means the sensors, whatever we are deploying for the physical world, okay, that should be secured properly, because here we are going to face different aspects. Okay, what are those aspects? We'll see that. Okay, the first one is temperature variance. Okay, then humidity fluctuation, then shock and vibrations. Okay, then solid particulates. Okay, then hazards kind of location, then environment can impact the equipment. Okay, so that is also possible. Then power consumption. Okay, so these are the different factors, okay, that will affect our sensor sector, which is exposed to the physical world. Okay, so what we need to do, we need to handle this in a proper manner. Otherwise, we may lose our hardware equipment which is deployed in the physical world. Okay, then connectivity, what we provide for device must handle these hazards. Okay, so in such type of a situation, if your network is continuous, then we don't have any issue over it. Say example like shock and vibration. Okay, so due to this, if there is a deflection in your network connectivity, okay, then we may lose particular that duration deflection. Duration whatever will be there, okay, during that we may lose some information from the sensor exactly. Okay, so connectivity must be continuous exactly. Remember, okay, such type of connectivity we need to establish over here. Then later, we'll go for the first layer, that is access network sublayer. Fine. This is the last mile we are calling it as. See what we have a sensor, we have a access network sublayer, will means the network between the gateway and the IoT devices exactly. Okay, so we are discussing about that network which is between the gateway and the sensor exactly, that we are calling it as access network sublayer. So each technology was designed with a certain number of use cases in mind. Okay, what to connect, where to connect, how much data to transport, at what interval and over what distance. Okay, so these are the few aspects regarding which, okay, each technology will be designed exactly, right? Obviously, okay, if you are generating a network between a gateway and a device, then these things should be concentrated. What we are trying to connect over here, okay, and how we are connecting them, where we are connecting them, what will be the data transmission rate, okay, so what is the distance between the sensor and the gateway, okay, such type of question will be arising. So these things should be addressed properly. Okay, so for this problem, okay, we are having a solution in the next slide. We'll see that what are those solutions in the. Okay, this use case determined the frequency band that was expected to be most suitable. Okay, the frame structure matching the expected data pattern. Okay, and the possible topologies. Okay, that these use cases listed. Okay, So based on these conditions, okay, we need to design what kind of network we need to establish or what kind of topology we need to establish over here. Okay, what should be the data pattern to be communicated between the gateway and the sensor? Such type of problem we need to address over here. One key parameter determining the choice of the access network or access technology is the range between the smart object and the information collected. Okay, so what kind of information you are collecting? First condition. Then second will be what is the range between the targeted device and the gateway. Okay, so this is very important. Okay, so in the next slide, we are listing some such type of uh, networks over here. Okay, just observe FAN, okay, HAN, NAN, FAN, and LAN. Okay, so these are the total 5 different types of network we can establish between the gateway and the sensor exactly. FAN means what? Personal area network. Okay, scale of a few meter. Okay, means the range will be of few meter exactly. Okay, so this is a personal space around a person. Okay, a common wireless technology for this scale is Bluetooth exactly. So Bluetooth based communication, whatever we have between the Bluetooth headphone and the mobile. Okay, so we are generating personal area network exactly. Then HAN means what? Home area network. Okay, so it is having a capacity of like tens of meter. Okay, so like Bluetooth range is of only for 10 meters exactly. Okay, but home area network will be having like more than, okay, like few tens, like 20 meters, 30 meters, such that exactly. Okay, this scale will be a bit more exactly. Okay, then NAN means neighborhood area network. Okay, see one thing you need to notice. So these are all the network. Okay, we are discussing based on what? Based on the range exactly. Okay, you can observe from PAN 10 meters to 20 meters we are increasing, then later up to 100 meters, few hundreds of meters. Okay, the neighborhood area network scale of a few hundreds of meter. Okay, the term NAN is often used to refer to a group of house units, okay, from which data is collected. Okay, if you are trying to collect the information from a group of houses, then we can go for NAN exactly, neighborhood area network exactly. PAN means what? Field area network. Regularly, we are using this field area network in case of IoT. Okay, scale of several tens of meter to several hundreds of meter exactly. Okay, PAN typically refer to an outdoor area large than a single group of house unit. Okay, means for one complete area. Okay, so the like NAN is for one first cross. Okay, but if you want to deploy the network for like 1, 2, 3, total 3 different crosses, okay, then we can go for PAN exactly. LAN, you already know, like local area network. Okay, scale up to 100 meters exactly. Right. So these are the different networks which is available. Okay. So according to our requirement, we need to use certain type of network, access network exactly. Then later, when it comes for the topology, okay, so here we can observe like 2 different topology over here. Point to point topology we have, point to multi-point topology we have. So this is the example for point to point exactly. Okay, star topology and cluster star is the example exactly. Okay, for point to multi-point, we are using mesh topology. See, you can observe this is what the gateway we are calling it as, and these are the sensors. Okay, if this sensor want to communicate with the other sensor, then it should be communicated to the gateway first, gateway to the other sensor exactly. So we don't have any other option between the sensors. Okay, we have only one option towards the gateway exactly. So this we call it as a star topology. Example for point to point. Okay, and one more is what? See, this dark like devices what we can observe that we are calling it as a full function devices exactly, means the gateways. Okay, so we are having a point to point connection between the gateway exactly. Okay, gateway exactly, but we are having a point to point like point to multi point we have between the gateway exactly. So here this point is connected to here also, and here also. Okay, point to multi point we are having. But when it comes for the sensors, okay, we are having point to point. But point to multi-point topology is also possible. Okay, most of the technology they are using. Okay, so this is what the condition exactly. Okay, you can observe the mesh topology. So these are the two concepts we need to address. Okay, when we are trying to connect our sensor to a gateway exactly. Now we'll go for the gateway. What kind of logic we are using for the gateway, and before that, like back to that, we'll be having a backhaul sublayer or backhaul network we are calling it as. So what is that backhaul network and regarding the we discussed? So data collected from a smart object will need to be forwarded to a central station where data is processed. Okay, and this is the case. Okay, data directly received from the sensor through an access technology needs to be forwarded to another medium, okay, the backhaul, and transported to the central station. Exactly. Logic is sensor we have. So from sensor to gateway, we are using those 5 different type of a network to communicate. So the information, whatever the sensor is retrieving, right? Okay, so that will be transferred to this gateway exactly. Now, in the gateway, we need to convert the data format into such a medium that, okay, the network which is available in the back end of the gateway, it should be suitable for that. Okay, the network what we are using in the back end of the gateway, we are calling it as a backhaul network. Yeah. So using this, we are transferring it for the application layer. Finally, the data will be processed exactly. Then later, the gateway is in charge of this intermediate communication. In most cases, the smart objects are static or mobile within a limited area, but the gateway will be always static. Okay, so this is the what the intermediate hub or intermediate junction where the information will be collected. Okay, we have a flexibility for the sensors, like it may be a static or it may be dynamic. Okay, we may be moving from here and okay, but gateway will be fixed always. Then later, throughput decreases as node-to-node distance increases. Throughput will be decreased as node-to-node distance increases, and it also decreases as the number of hops increases. As the number of hops increases. So we should go for some limited kind of resources available over here. Okay, we should not, like, if you are available with 100 sensors, okay, if it is necessary, we need to use, otherwise we should not use them. Remember this, okay, because it will reduce the like quality level of the network. Remember, the gateways are the nodes which collect all the data from smart devices and transfer those to core for processing. The medium used may be wired or wireless. So this medium is called backhaul. Okay. So here for processing whatever we are transferring, the network we are calling it as backhaul network. Okay. So this may be wired network or wireless network. It doesn't matter exactly. Then later, now we'll be going for the protocol what we are using. Remember. Okay. A network transport sublayer. Okay. A network protocol is specific with specific characteristics, okay, needs to be implemented. Okay, the protocol need to be open and standard based to accommodate multiple industries and multiple media. Okay, so we need to go for an open kind of a protocol available over here, because we need to deal with different software over here, different aspects, different company-based application we need to deal over here. So we need to go for open-based protocol over here. Okay, fine. We'll see that. What is suitable over here. Scalability and security are almost common requirements. Okay, IP is a protocol that matches all these requirements exactly. Okay, scalability is what, like the number of devices, how many we can handle. Okay, at a time. That is what the very important thing. And the security for the network. So these are the two very important requirements. So IP is the better option. Okay, if you want to go for a protocol for this IoT network. The flexibility of IP allows this protocol to be embedded in objects of very different natures. Okay, then exchanging information over very different media, including low power, lossy, and low bandwidth networks also. Okay, so this is bit light exactly, so it can be fitted for the smart object, whatever we are using. Finally, the transport layer protocol built over IP like UDP and TCP can easily be leveraged to decide whether the network should control the data packet delivery with the TCP, or whether the control task should be left to the application UDP. So here we are, when we are getting into the concept of protocol, okay, then IP-based protocol, then two things we need to encounter. One is what UDP and the TCP. Okay, it is up to you, like whether you want to go for a transmission control protocol or user data control protocol. But for the IoT, okay, compared to TCP, UDP will be much lighter. Okay, so UDP is better for using in case of IoT network exactly. Yeah, so UDP will be preferred. Okay, then IoT network management sublayer. Okay, so here using TCP and UDP will be bringing the information to the upper layer. So this is the junction between the application layer and the network layer exactly. So here what we need to do, we need to convert the data format in such a form, like what application software is expecting exactly. So for that, we are dependent on what HTTP, okay, hypertext transfer protocol. So we'll be using this particular protocol over here, which is working in a fashion of a client server exactly. Okay, so here server part will be the application layer, okay, and the client part will be the sensors exactly. Okay, so whatever sensor is sending the information, that will be communicated to the application layer exactly. Okay, and later, out of which we are using WebSocket is part of the HTML5 specification. Okay, and provides a simple bidirectional communication over a single communication. Okay, single connection. Okay, so we are using something called as a WebSocket. Okay, which is a part of HTML5. Okay, for converting the data format over here. Okay, so which will allow us to have a bidirectional communication. That is a very important thing. Some IoT solutions use WebSocket to manage the connection between the smart object and an external application. Okay. So apart from that, we are using one more thing called as a COP. We are calling it as a constrained application protocol. Okay. Uses some method similar to those of HTTP, such as get, post, put, and delete. Okay. But implements a shorter list, like head length will be bit less exactly. So these are the few concepts. Okay. We will be discussing this in detail, okay, in different modules. Okay. So this is how we are converting the information to the upper layer version exactly. Now, when it comes for the application and analytics layer, okay, so here we are going through some four different types of analytics exactly. Analytics means what? Whatever the information you are receiving, that should be processed. That's it. Okay. So here, analytics application we are having means whatever the information you are receiving, that will be analyzed and result will be displayed. That's it. Okay, information will be displayed. That is what the action we are taking over here. But second type of application we are having, like control application, like information we are receiving, whatever the information we are receiving, that will be analyzed and we are taking some decision over here. That decision will be conveyed to the smart object. Okay, because of which the behavior of the smart object or the object which is related to that sensor, okay, will be changed exactly. Okay, so now here there are the two different varieties exactly: analytics application and control application. There are two different varieties. Sometimes we will be dependent on analytics application, sometimes we will be dependent on control application exactly. But nowadays, the advanced kind of system, okay, what they are providing is they are having a combination of analytics and control application. Like they are having the potential to analyze the information and also take certain action exactly. Remember this. Okay, the combination version also we are having. The result of this processing may be used to modify the behavior of smart objects or system related to the smart object. The control module is used to convey the instruction for behavioral changes. Okay, so this is what we can achieve by using control and application analysis. Then later, data analytics we are having. This type of analytics processes the data collected by smart object and combines it to provide an intelligent view related to the IoT system. Okay, data collected from thousands of sensors may be combined and then processed exactly. So here, like information, what we are grabbing from thousands of sensors, okay, should be collected in one location. Okay, after taking the opinion from all the sensors, we need to come for a final conclusion. Okay, that is the part of data analytics exactly. Okay, then network analytics. This is very important. Most IoT systems are built around smart objects connected to the network. A loss or degradation in connectivity is likely to affect the effective efficiency of the system. Such a loss can have dramatic effects exactly. Okay, so we need to have some analytics or some observation over the network also, because we are totally dependent on the network. Okay, due to some reason, maybe our network not perform well. Okay, because of which we may not achieve the efficiency properly. Okay, so these are all aspects should be analyzed properly by what application layer itself. Here, see, job of application layer is what? If there is a problem with the network, should be identified and should be resolved. Then later, the large amount of information you are receiving, that should be handled properly. And after consuming that large amount of information, we need to come for a final conclusion. That is what. Then later, like the control. Okay, based on those information, we need to control the devices. Sometimes we need to display the result. That's it. Okay, so these are the three different layers of IoT architecture: things, then network communication layer, then later application layer, okay, regarding which we had a complete discussion. So in the next session, we'll be going regarding the like IoT management layer stack, okay, cloud, fog, and edge. Regarding that, we'll be having a complete discussion. So this is very important question. Okay, they may ask you in general, like explain the core IoT architecture, okay, or else they may particularly specify the sub-layer, okay, or else like communication network layer, then you need to explain the four different layer, application layer, you need to different, explain four different analytics system, okay, okay, so this is it for now. So we'll meet with the further architecture layers in next session. Thank you, students.